Safety stock is essentially inventory that you keep just in case something unexpected happens. Setting a reorder point, like when are we going to order new stuff, is essentially a decision in setting safety stock. This question is hitting on that point. The reorder point for SKU 303 is 102 units. Okay, so SKU 303 is just some certain thing that we keep around. The reorder point is 102. When we're down to our last 202 units, we reorder more of this stuff. Okay, fine. While the average demand during lead time for SKU 303 is 97. All right, average demand during lead time is 97. What's that mean? It means that usually while we're waiting for a new order, what we need is 97. We reorder at 102, but usually we only use like 97 before the new order gets there. Okay, fine. What is the safety stock implied by that reorder point? You can see the basic relationship there. Safety stock, how much you're keeping around just in case something unusual happens, is essentially the reorder point itself minus expected demand during lead time, or what I used up here, the mu for the average demand during lead time. Oh, right. How much you're keeping around just in case is basically when you reorder less what usually happens. That part that's left over would be the part that's just in case. Oh, so for this question, the only thing you have to do is line up the actual numbers that were provided. The safety stock is, well, okay, we reorder at 102. Usually we use 97. That yields, what is that? Okay, 5. That policy is implying 5 units of safety stock. That in general, 5 units of inventory are kept around all the time, just in case. Now the next question is also about safety, but not safety stock. A certain company reorders envelopes when its stock drops to 12. Oh, all right. That right there is a reorder point of 12. Although demand for envelopes during lead time is normally distributed with a mean of 10. Okay, so kind of similar to last time. The demand during lead time is 10, except it says some more detail and a standard deviation of 3. So the standard deviation in demand during lead time is 3. All right, fine. What is the probability of this company stocking out? So it's not asking about the safety stock itself. The safety stock, if it had asked what the safety stock was, right, we'd be happy because that would be really, really easy to calculate. The safety stock for this particular situation is the reorder point 12 minus the average demand during lead time 10. We could just say 2, but that's not what they're asking. They're asking what's the probability that you'll actually stock out. I always draw a picture, okay? The easiest way to see this is to draw a picture. What is it a picture of? Demand during lead time. That's what we're not certain about. Okay, so I'm going to try to carefully draw a picture of demand during lead time. It looks like a bell-shaped curve. So I'm trying to draw a bell-shaped curve. Why does demand during lead time look like a bell-shaped curve? Because we were told that. It said during lead time is normally distributed up here. Okay, so this is every possible amount of demand, a number line down here, every possible amount of demand during lead time that could happen. The center of the curve, what's most likely is that 10, the average demand during lead time, right? That's the mu. And then kind of the degree of spread or laziness of this particular curve, right, is captured in the fact that the standard deviation is 3. But there's more to the story. A reorder point has already been set, and it's been set at 12. So that would be some number over this way. What was the question? Stocking out. Okay. Remember that this is a number line down here that represents every possible amount of demand during lead time. You'll only stock out if demand during lead time is higher than the reorder point, because it means you used up all that stuff and then there was no more. Okay, so only this portion of the curve right here to the right of 12, because that's 13, 14, 15 and higher numbers, only these represent scenarios in which you actually do stock out. And the height of the curve over any one number down here is telling you the probability of that particular value, which means that the area of the curve to the right is indicating the overall proportion of times that that happened, which is a visual representation of the so-called stock out risk. This curve represents everything that could possibly happen during lead time. How much of it has been amputated here? It's stranded to the right of the reorder point. That's the probability that you actually will stock out, that demand will exceed supply during lead time. So we just have to figure out how much that actually is. Okay, we have to figure out what the area of the curve that is caught to the right here in my sketch. So I wish I had a table that told me, you know, that like for drawing a certain line at a certain number like 12, what the area of the curve would be to either side of that line for, now wait a minute, not just any curve, for my curve. My curve has a center of 10 and a standard deviation of 3. Well, there's no such table. There's no such table that's going to tell me an area on the curve that has a mean of 10 and a standard deviation of 3. But there is a very, very common table in the back of your textbook, in the back of most math textbooks. It's a very common tool. And it just gives us areas of the curve. Now you have to be careful. This is actually the next page. It's also bundled into this note frame. It gives us the area of the curve to the left of, but that's almost as good as, we can use that. We can work with that. It gives us areas of the curve to the left of some number that we're interested in. But this normal curve up here, it's not a curve that has a mean of 10 and a standard deviation of 3. It is a standard normal curve. A standard normal curve, the mean is 0 and the standard deviation is 1. You say, well, fine, but what good does that do me because I'm working with a curve whose mean is 10 and the standard deviation is 3. We can translate any particular curve like this one into a standard normal curve quite easily by completing the following computation, the z-score. Okay, z-score, or what number should I look up on this table that would correspond to my particular curve? I take the number that I'm interested in minus the center of my curve divided by its particular standard deviation. So for this problem, I'm calculating a z-score. The number that we're interested in is 12, right? That's what we're evaluating. Minus the center of our curve is 10. The standard deviation is 3. Okay, so this works out to be 2 divided by 3, or 2/3. Right? Or in decimal places, 0.67. What am I supposed to do with that? That corresponds to this on this particular curve. Look it up in the table. Look it up on the table. Now, with a z-table, how do you use a z-table? You've got this score, right? The first 2 digits, 0.6, tell you the row to look on, and the third digit, the 7 in our case, tells you which column to look in. All right, well, I'm going to need reading glasses here. 0.6. 0.6, right, 0.6 is the row, but I have to go all the way out here to 0.07. 7 is the column. I am looking for what's at the intersection of those, and it says 0.7486. 0.7486. 0.74. What does that mean? 0.7486. The z-table is telling me that for our reorder point of 12.7486, about 75% basically of the curve is to the left. The z-table is reporting what is to the left of the number that you're interested in, right? Oh, and we have a term for that, because the area of the curve that's safely to the left of the reorder point, that's the service level. That is the probability that you will have enough during lead time. Oh, now wait, maybe we better return to our own particular situation. That was this one. Okay, so what we found out is 0.7486 of the curve, right, is caught to the left. We want to know how much of it's caught to the right, so we say 1 minus 0.7486, or 0.2514, or basically 25%. That rounds rather nicely to 25%. That's the answer to the question, because the question was, what's the probability of stocking out? And in finding out that 25% of this curve is to the right of the reorder point, we have found out that there's basically a 25% chance of stocking out every time you place a new order. 25% of the time, that 12 that was originally in stock when you placed the order, it's not going to be enough.